Okay, you guys. Noah and Savannah, hopefully you can see my screen. Noah, we can see it. Awesome. Very good. Okay, so I want to talk to you guys about the Bohr model of the atom, and we're going to look at drawing Bohr models of the atom. These are very, very helpful in certain instances in chemistry and in physical science. His model of the atom was not 100% correct. He got some things right and some things wrong. Where he was correct was he thought that there were energy levels outside of the nucleus where the electrons resided. And he was totally correct, okay? There are actually 7 energy levels on the electron cloud. Let me see if I can... Okay. There are 7 energy Can you see? Oh, dang it. Thank you. I'm glad you said something. Let's try that again. 7 energy levels. Better? Okay, there you go. So there are 7 energy levels outside of the electron cloud. Okay. I'm going to show you pictures of what the cloud actually looks like, and then we're going to break down how it's actually organized. But there's a little bit you have to understand before we can jump into making these Bohr diagrams. Okay. There are 7 energy levels in the electron cloud, and they go from close to the nucleus all the way out. So number 1 is closest to the nucleus, number 2 is a little further away, so on and so forth. Our Bohr models, they represent the energy levels with rings around a central nucleus. Okay? So before we can go any further, you need to know how many electrons can fit on each energy level. Okay? So energy level 1, which is closest to the nucleus, can hold a maximum of 2 electrons. That little E, does that make sense for electrons? E with a little dash. So energy level 1, closest to the nucleus, can hold 2 electrons. No more. Okay? If we have more than 2 electrons, we have to move to the next energy level, which is energy level 2. Okay? Energy level 2 is a little bit bigger, it's further away, and it can hold a maximum of 8 electrons. Energy level 3 is bigger, it's further from the nucleus, and that can hold a maximum of 18 electrons. Energy level 4, it is still bigger. It can hold a maximum of 32 electrons. Now, energy level 5, 6, and 7, so 5 through 7, ooh, that's a funky looking 5. Energy level 5 through 7, okay, are identical to energy level 4. So each of them, 5, 6, and 7, can hold a maximum of 32 electrons. Now, 2 types of electrons we're going to be dealing with. We're going to be dealing with core electrons So core electrons are all of the electrons in the energy levels not, let me repeat that. The core electrons are all of the electrons excluding the ones on the last energy level. Okay? Core electrons. So they're electrons not on last energy level. You think you guys can make a little note that EL is energy level? So the core electrons are electrons that are not on the last energy level. capital EL, energy level. We also have what we call valence electrons. Valence electrons. Now, if the core electrons are the electrons not on the last energy level, the valence electrons are the electrons on the last energy level. So valence electrons are electrons on last energy level. These guys are the electrons that are involved in chemical bonding. So when our chemical compounds are made, you guys, it's the valence electrons that are transferred or that are shared to make our chemical compounds. It's not those core electrons. Okay? This is a little information you have to know before we can move into making Bohr diagrams. Okay. We're going to jump right over here to a new slide. Some things you need to know. Bohr diagrams are just diagrams that show the number of protons and neutrons in the nucleus. It shows the core electrons, and it shows the valence electrons. So let's just make a little key here. So our Bohr diagram, come on, right, please. Bohr diagram. Okay, so the rings represent our energy levels. Okay, our dots are going to go ahead and represent the electrons. Okay. This one? That's diagram. I don't even know how to spell it. Thank you. I was like, is there an H in there? There we go. Okay. So rings are the energy levels. Dots are the electrons. Again, total, how many energy levels are in the electron cloud? 7. Okay. So let's go ahead and pick an element. Let's go with phosphorus. Okay. We're going to draw the Bohr diagram for phosphorus. So the first thing we need to know is we need to know how many protons phosphorus has. So make sure your periodic table is handy. And somebody shout it out. How many protons? There are 15 protons. We definitely need to know that. I'm just going to write it off to the side here. The next thing we need to know is we need to know how many neutrons. So find the atomic weight for phosphorus and round it to the nearest whole number. And what number do you get? 16 neutrons, or what's my... Okay, so first of all, can you tell me what the atomic weight is? Just to make sure everybody's on board, Ben? Okay, so we round it to 31, okay? So your atomic weight, you round it to the nearest whole number, which is 31. And then, like Ezekiel did, we are going to subtract the number of protons, and that is going to give us the number of neutrons, which is 16. We need to know one other thing. We need to know how many electrons are in a phosphorus atom. If there are 15 protons, how many electrons are there? There are 15 electrons. That was like a semicolon right here. So, okay. So now we have all our information. So the first thing we're going to do is we are going to go ahead and make our nucleus. We are going to put, I don't know if I'm going to run out of room here. I'm going to put my 15 protons in the center, and I'm going to put my 16 neutrons in the center, and I'm going to make myself a little nucleus right here. Now, I have to represent my 15 electrons on rings. Okay? So my first ring is my first energy level. And how many electrons fit on that first ring? Ben, and you are more than welcome to move to one of these desks if it's difficult to see. Same with you, Aubrey. If you guys want to move, you guys are more than welcome to. So energy level 1 can hold how many electrons? 2, maximum 2, right? Okay, so I'm going to stick 2, and I'm going to just represent it with dots. I'm going to stick 2 right here. And that's all that can fit. No more can fit. Okay, so my next option is I have to move up the next energy level because I have to put 15 electrons someplace. So I'm going to move up to the next energy level, and I'm going to represent that with the ring. And how many can fit on energy level 2? 8. So I'm going to put 8 dots. 1, 2, 3, 4, 5, 6, 7, and 8. Now, right now, we have a total of how many electrons? Just right this second on my Bohr diagram. I got 10, but how many do I need? I need 15, so I got to add one more ring. And how many electrons are going to go on my last ring? 5. So 1, 2, 3, 4, and 5. That's my Bohr diagrams. Okay, let's go ahead. Let's try another one. Let's go ahead and look at. Now these are only good up to argon. The only reason we can only use these elements or these Bohr diagrams up to argon is because in reality, the electron cloud is much more complex than just rings. Okay, so Bohr was on to something. Bohr diagrams are definitely helpful for certain things, but they only work up through argon because the real structure of the electron cloud is quite a bit different than the ring idea. Okay, so let's go ahead and look. Let's look at magnesium. Okay, so go away. I don't know how that goes away. Review. Okay, so let's look at magnesium, Mg. So we need a little bit of information. We need to know how many protons. So how many protons does magnesium have? Excellent. We need to figure out neutrons, right? So we take the atomic weight and round it to the nearest whole number and then subtract my number of protons. So 12 neutrons, thank you. Neutrons 12. And how many electrons does magnesium have? 12? Very good. Okay, so let's go ahead and start. I'm going to put my 12 protons and my 12 neutrons in the center. I'm going to make my nucleus. And I'm going to draw my first ring. How many electrons are going to go in the first ring? Excellent. Put 2 there, 1, 2. And then next ring will fit a maximum of how many? 8. And 8. And do we need one more ring? We do. How many electrons are going to go in that last ring? 2. Very good. Okay. Pretty easy, right? Not too tough. Okay, so just a quick observation here. These two electrons on the last energy level, these guys are our valence electrons. So this is my last energy level that has any electrons on it. So those are considered my valence electrons. All the electrons on energy level 1 and 2, these guys are core electrons. So all the electrons on energy level 1 and energy level 2 are core. The ones on the last energy level are valence electrons. So if I was to go back to our phosphorus Bohr diagram, how many valence electrons does phosphorus have? Louder? We're just going to count in the dots on the last energy level. So 5 valence electrons. Okay? So on this diagram, this guy has 5 valence electrons. And how many core electrons does this guy have? The core electrons are all the other electrons, not the ones on the last energy level. Louder? 10. Very good. We've got 10 core electrons. Excellent. Very good. Pretty easy? Sweet. Okay, so I'm going to move on to, and we're going to go back to some drawings, but there's a little bit of information that we need to go ahead and take down before we get back to some diagrams. So when it comes to the electron cloud, and in order for me to record this, you guys, I can't put it as a presentation, so this is going to have to work, okay? So when it comes to the electron cloud, electrons can jump from lower energy levels to higher energy levels if they absorb energy. And energy can be the form of heat or the form of light, okay? So in chemistry, which is what we're learning about right now, when we are talking about a very specific amount of energy to get an electron to go from a lower to a higher energy level, okay, we call it a quantum of energy. Now, a quantum of energy is a very exact amount of energy to get an electron to go from a low energy level to a higher energy level. So if an electron is going from energy level 1 to energy level 7, that is a pretty big jump. So it's going to need a large amount or a large quantum of energy to make that jump. If the electron is going from energy level 1 to energy level 2, okay, that is a very small jump. So it's going to take a smaller amount or a smaller quantum of energy to make that jump. So when electrons are on their original energy level, so imagine in your brain like your rings, when they are on their original energy level, okay, we say that the atom is in its ground state. When the electrons have jumped to higher energy levels, okay, we say the atom is in its excited state. go too fast. Now, I'm about to say something else. So if I quickly went back to our Bohr diagram, what I'm talking about is, so for instance, if we have this magnesium atom, if it absorbs energy, again, heat, light, electricity, any of those types, then its electrons, like maybe this electron, is going to go ahead and absorb energy, and then it's going to jump to a higher energy level. Okay? Now, it has to absorb a perfect amount of energy to go from energy level 1 to energy level 3. Kind of think about it like if you were buying something from the candy machine. You know, you have to have exactly $1.50 to get a Snickers. Okay? If you put in $1.25, you're not going to get that candy bar. Okay? Same thing here. You have to have an exact amount of energy to make certain jumps. And think of energy like money going into the candy machine. Exact amount of money to get whatever you're looking for. Okay? Now, there's one more piece to this. You guys remember Roy G. Biv? You guys have heard of Roy G. Biv. So white light is composed of our different colors of light. Okay? And these different colors of light hold different amounts of energy. Okay, so just kind of quick review of electromagnetic spectrum and electromagnetic energy. All of these colors of light, all of these make up white light. The reds and the oranges and the yellows carry low energy. Okay, and your indigos and purples and blues carry high energy. Okay, so what happens is this, is when an electron jumps to a higher energy level, okay, it eventually comes back down. It comes back to its original energy level. But what happens is that energy that it absorbed to get up to a higher energy level has to go somewhere. So it jumps to a higher energy level, and when it comes back down, it emits what we call photons, or it emits colors of light. And the colors that those electrons emit depend on how big of a jump that they make. So, and I know you're writing, so I'll come back to this. So, for instance, okay, if I'm looking at this guy right here again, let's go back. Let's go to this guy. So if I'm looking at this Bohr diagram, if this guy, we'll use this guy, if he jumps from energy level 1 to energy level 3, okay, it's going to take more energy than if he was to jump to energy level 2, because it's just further away. Does that make more sense? I mean, that makes sense. If you have to climb a ladder that's very high versus climbing the ladder only halfway, it's going to take more energy to get higher, okay? So what happens is this. If it makes a large jump, okay, it will emit colors like blues and like indigos that indicate that it took more energy to get up there, okay? If it makes a small jump, just like from energy level 1 to energy level 2, when it comes back down, it's going to go ahead and produce or emit colors like the reds and the oranges, because that carries low energy, and it didn't take much energy for it to jump up here. I'll put this back here. So certain colors of visible light are emitted. Yes. Yes. Are we good? I can move to the next slide. Okay. So, like I was saying before, the bigger jumps that they make, okay, the more energy it takes to get from a low energy level to a high energy level. And so when it comes back down, when the electrons come back down, they're going to emit different colors of light depending on how big the jump was. If it was a big jump, when they come back down, they're going to release light of high energy, blues and purples, indigos, okay? If it was a small jump, when it comes back down, it's going to emit colors of light with low energy, reds and oranges and some yellows.